All right, so in this lesson, we're going to go through more examples of combinatorics. Okay, example 1. 6 male students and 4 female students apply for a job. In how many ways can 3 jobs be given amongst the students if, and there are a few of them, I'm going to start with the first one, no restrictions. And then we're going to go through and look at the other part as well. So if there's no restriction, then you have the total number of applicants is 10, so 6 plus 4, that would be 10. So in this case, it's very simple. You just go 10, choose, and there are 3 jobs. What is that? Well, that is 10 factorial over 3 factorial times 10 minus 3. All right, you take out your calculators and then punch that in, and let's see what you get. And the answer is 120 possible ways that you can have this specific condition. Okay, let's look at the next question. We have next question right here. 2 males and 2 female students must be hired. So that's the restrictions that we have. Well, in this case, we have how many total male students? 6, and we have total 4. So in this case, we have to choose 6, choose 2, that would be for the male students, and then 4, choose 2, that would be for the female students, and we have to multiply them. And that's what we have to do. So let's go ahead and do the math on that one, and your answer will end up being 15 times 6 will end up being, all right, so here it is. That's 90 different ways of being hired, 2 males and 2 females exactly. And then let's look at this one. It says at least 2 jobs go to female students. So how many jobs do we have already in that is out there? Is 3 jobs, but 2 of them minimum have to go to the female students. So this is the range question. That means that you have to include. When it says at least, so it should say, so that would be 2 female and plus 1 male, and then or it says at least, right? Could be 3 female and 0 male, and those are the 2 options that we have. All right, so in the first case, we got 2 female out of how many students? The original out of 4, 4 choose 2, and then here you multiply that by 6 choose 1 for the male. So that's the first one. This or means plus. And then you include the other one. So that would be 4 choose 3. And then this would be 6 choose 0. And then you have to go ahead and you do the math on that one. And your answer will be 36 plus 4. All right, so that's the first question. Let's look at the second question. Here it is. You have a toonie, that's $2. That's a coin in Canada. A loonie, a quarter, a dime, and a nickel. How many sums of money are possible if you choose only 3 of the coins at random? All right, so we're going to go through this question. It's a very interesting question, very good question, actually. So let's find out. In this case, notice that order does not matter. So any 3 coins will add up into a sum of money with whatever that is. And then we're just going to go ahead and add them all up. All right, the total number of coins that we have is 5. Okay, very good. So, and then for each one, we just need R is the 3 that we are choosing, and this just simply 5 choose 3, and that's 5 factorial over 3 factorial times 5 minus 3 factorial. And then you just go ahead and use a calculator to find out what that is, and the answer is 10 different sums of money that you can make out of the 3 different coins that you can take out of the 5 that you have here. All right, let's look at the other question. Okay, so how many 4 of a kind hands are possible in 5-card poker hands? Now, just a review in here, just that if you don't know, a poker game consists of 52 cards in deck, and there are 4 different suits there. And 4 of a kind, the first thing is that, so if there are 4 we want, the first thing is that you're choosing 4 of the same type of card, okay, 4 of a kind. So if it's 4 jack, you're going to have all 4 of them. That's where 4 choose 4 comes from. That's number 1. Number 2, the other part is that how many different cards do we have in each suit? Well, there are 13 of them, right? And we need 13 of those. That is, each one can have a 4 of a kind. So we have to take that and then multiply it by 13, choose 1. Okay, so that represents right here, that represents the 4 of a kind. Then we have to include the last card. And the last card out of the 4 card that is out of 52, there is 48 left. And then you have to multiply that by 48, choose 1. Okay, so that's really, really important. The first 2 expression is the 4 of a kind, but not including the last card. And then last card is that one odd card that is at the end. All right, so you go ahead and then you multiply, you will end up getting 624 different possible 4 of a kind hand. That's what you will get. Very, very good. Okay, next question. And that is, how about a full house, which is 3 of a kind and a pair? So for example, 3 jacks and 2 tens, that would be it. So, and this one is basically using the same concept. So the 3 of a kind is your 4 choose 3. That's very simple, obviously. Now, you go ahead and you notice that there are 13 different ways to do this one. So you have to multiply by 13, choose 1. And then you have the pair. So for the pair, which is, I'm going to put it in here as pair, that would be 4, choose 2, because you're choosing 2 out of the 4 same value. So in this case, pair means like 2 twos, 2 jacks, 2 queens. And there are how many different numbers of cards we can have a pair? Well, that would be 12 of them. So that would be, you have to do the multiplication of 12, choose 1. Okay, that's the multiplication for that. And then you put them all together and you have to multiply the top part by the bottom part. So at the end, we will get 4, choose 3, multiply by 13, choose 1, multiplied by 4, choose 2, multiplied by 12, choose 1. And then you put them all together and your final answer will end up being 3,744 different full house possibilities. So full house hands that you can have. Now remember, the first 2, that is 3 of a kind. The second 2 is the pair. All right, so that's the answer to that one. I hope you found this useful. Check out the next video.